I just wanted to give a really quick explanation of exactly what's happening with the dipping duck experiment. It's one of my favourites, and it's a really nice little experiment which has got lots of features of physics in it. It's very simple. It's just a glass tube in a duck shape with some water in it. If I just hold this up, I can show you that we've got water in my little cup. And it's a really straightforward experiment that involves lots and lots of different parts of physics in it. So, if you look very carefully, what you'll notice, I'm not sure if you can see it, but the red part of this duck is made out of felt, and the felt has been submerged in water so that it is completely sodden. That's really important for this experiment. In this beaker, as I've just shown you, is some water, and that water is at a temperature below room temperature. That's another really important point. Now, the other part of this is this kind of bulbous tube, okay, with some blue liquid in. And if you look very carefully, what's happening is that the blue liquid is appearing, it's rising up this tube, okay? Now, the reason it's rising up the tube is because of the water being below ambient temperature. So this is what's happening. As the duck dips its bill, it's collecting water onto the felt. Because of the ambient temperature of the room being hotter than that of the water, that water gets heated up by the ambient temperature and starts to evaporate. And as it evaporates, it takes heat energy from inside the kind of evacuated airspace in the bill. As that airspace gets colder, and you'll know this if you're doing A-level physics or if you've got a general interest, as the temperature of a gas reduces, the volume it takes up also reduces, it becomes smaller. And so as that becomes smaller, it reduces the pressure, the air pressure in the head. Now that the air pressure outside is much larger rather than the air pressure in the head, the water becomes forced up the tube. So that's what this rising blue liquid that you'll see in just a second is. There we go. It's the air pressure down below higher than the air pressure in the head, and so the liquid gets forced up. And that brings us on to the second part of this. So the first part is that you've got a cold head cooled by this colder than ambient temperature water, and a much warmer bulb at the bottom and ambient temperature outside. That's forcing the water up. The second physics part of this is to do with moments. And so what's happening is that as this liquid is rising up the tube, the center of mass, where the balance point, if you will, of this whole apparatus is, moves further than this pivot point here. And as it tilts further past here, just like a seesaw, as it tilts further and further, it means that this end here becomes heavier than this end here. And so when that happens, you get a seesawing effect, which tilts the head down. The one question then is, why is it that when it tilts down, it doesn't stay down? Because now all the liquid is. And as you'll see, actually, as it tilts up, so we'll just wait one more revolution, you'll see that as it tilts down, very quickly, this tube of blue liquid just here actually evacuates. It runs right down the tube again. Now, the reason for this, as you'll see, so just a second, it's rising up to the top, the head's about to dip. As if on cue, it dips, and then you'll see that the liquid runs out of that tube. And the reason for that is that it then forms an air gap, and it breaks the seal between the water and the tube. As it breaks that, it means that the air pressures can equilibrate, and when they equilibrate, we reset back to zero. So that, in a very simple, quick, and rather rubbish explanation, is why the dipping duck will continue. Now, interestingly, please go and buy one and try it at home. It costs, I don't know, £5, something like that. This isn't mine. It will continue to do this for as long as the water is colder than the ambient temperature outside. As long as the water is colder than the air, it will continue to do so. So it's not a perpetual motion machine, it won't carry on forever, but it will carry on for a long time if you insulate your container with your water in it. All right, thanks very much. Cheers.